In this video, we are going to study for a given point P, x1, y1 in Cartesian plane, x and y, how we can write vector OP bar as x1 I cap plus y1 j cap, where I cap is a unit vector along x-axis and j cap is a unit vector along y-axis. And when we write OP bar equals x1 I cap plus y1 j cap, this is known as resolution of vector OP bar along x and y axis, where x I cap and y j cap are rectangular components of vector OP bar along x and y axis respectively. Also, vector A bar and vector B bar, which emerge from point O, are any two vectors which, as we know, are always coplanar, which also form adjacent sides OA and OB of parallelogram OACB, and a third vector C bar coplanar with A bar and B bar along the diagonal OC bar of this parallelogram if length OA is LA bar and length OB MB bar, where L and M are any two non-zero scalars. Then we can write C bar equals LA bar plus MB bar and call this expression C bar as linear combination of A bar and B bar, and that also implies coplanarity of A bar, B bar and C bar. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Let Px, y be a point on the plane. PL is perpendicular on x-axis and PM is perpendicular on y-axis. Joining P with the origin, we get position vector of point P, OP bar. By triangle law, OP bar will be OL bar plus LP bar, which is OL bar plus, here LP bar is same as OM bar. Let I cap be a unit vector along x-axis and j cap be the unit vector along y-axis. So OL bar will be this x into unit vector I cap plus OM bar will be this y into unit vector j cap. And if we denote this OP bar by R bar, then R bar will be x I cap plus y j cap. For any point Px, y, OP bar can be uniquely expressed as x I cap plus y j cap. In short, what we understand here is we can express position vector of any point P in terms of unit vectors I cap and j cap along x-axis and y-axis respectively. Unit vector, as we know, is any vector with magnitude 1. So here mod I cap is same as mod j cap equals 1. Let us remember that OP bar can be uniquely expressed as x I cap plus y j cap. If it is not unique representation, then let us assume that x1 I cap plus y1 j cap and x2 I cap plus y2 j cap are two representations of the same point P. Then they must be equal. Therefore, x1 I cap plus y1 j cap equals x2 I cap plus y2 j cap. Rearranging the terms, x1 minus x2 I cap equals y2 minus y1 j cap. That implies x1 minus x2 equals 0 and y2 minus y1 equals 0, and this together implies x1 equals x2 and y1 equals y2. Hence, OP bar equals xi cap plus yj cap is unique representation and not these two representations. In fact, they would be one and the same. If coordinates of point P are 8, 6, then vector r bar will be 8 I cap plus 6 j cap and its magnitude mod r bar will be r equals square root of 8 square plus 6 square, that would be square root of 100 or 10 units. If I cap is unit vector along positive x-axis and j cap is unit vector along positive y-axis, then any vector r bar in the plane can be expressed as r bar equals x I cap plus y j cap, where x and y are any real numbers. Here x I cap and y j cap are called rectangular components of r bar along x and y axis respectively, and the process is called resolution of a vector in 2D, two dimensions. Let OA bar equals A bar, OB bar equals B bar, and R bar be any vector coplanar with A bar and B bar. Draw PL parallel OB so that LP bar equals MB bar and OL bar equals LA bar, where L and M are some scalars, that is some numbers. Now by triangle law, OP bar equals OL bar plus LP bar, that is R bar equals LA bar plus MB bar. This means if R bar, A bar and B bar are coplanar, then R bar is a linear combination of A bar and B bar, and it is written as R bar equals LA bar plus MB bar. Suppose P has coordinates x, y, z. Let Q be the foot of the perpendicular drawn from P to the xy plane. Let R and S be the foots of the perpendiculars drawn from Q to the x and y axis respectively. Let vector OP bar equals R bar. Let OR equals x, OS equals y, and QP equals z. Therefore, OR bar equals x I cap, RQ bar equals OS bar equals y j cap, and QP bar equals z k cap. Now OP bar equals R bar equals OQ bar plus QP bar. Now by triangle law, OQ bar is OR bar plus RQ bar plus this QP bar, which is x I cap plus y j cap plus z k cap, where I cap, j cap and k cap are the unit vectors along x, y and z axis. Please note that angle OQP is a right angle. Therefore, in right triangle OQP, OP square equals OQ square plus QP square. Again, in right triangle ORQ, this OQ square will be OR square plus RQ square plus this QP square, which is this x I cap square plus this yj cap square plus this z k cap square, which finally gives us OP square equals x square plus y square plus z square, because I cap square equals j cap square equals k cap square equals 1, being a self dot product. So we write here mod OP bar equals square root of this x square plus y square plus z square, or mod R bar equals R equals square root of x square plus y square plus z square. If P is 1 minus 1 1, Q is 2 minus 4 minus 3, then we have to find P bar, Q bar p bar plus q bar and p bar minus q bar. So first let us join p and q to the origin. So OP bar becomes p bar, OQ bar becomes q bar. So OP bar, which is p bar, will be 1 I cap minus 1 j cap plus 1 k cap, that is I cap minus j cap plus k cap. Similarly, OQ bar will be q bar, which is 2 I cap minus 4 j cap minus 3 k cap. Next we have to find their magnitudes. So magnitude of p bar will be mod p bar, which will be square root of this 1 square plus this minus 1 square plus this 1 square, which will be root 3. Similarly, magnitude of q bar will be mod q bar, which will be square root of this 2 square plus this minus 4 square plus this minus 3 square, which will be square root of 4 plus 16 plus 9, that will be root 29. Next we have to find p bar plus q bar, that will be I cap minus j cap plus k cap plus 2 I cap minus 4 j cap minus 3 k cap, which will be 1 I cap plus 2 I cap 3 I cap minus j cap minus 4 j cap minus 5 j cap k cap minus 3 k cap minus 2 k cap. Next we have to find mod p bar plus q bar, that will be square root of this 3 square plus this minus 5 square plus this minus 2 square, that will be square root of 9 plus 25 plus 4, that will be square root of 38. Next we find p bar minus q bar, which will be this 1 minus 2 minus 1 I cap, this minus 1 minus 4, that is 4 minus 1 3 j cap, and this one minus 3, that is 3 plus 1 4 k cap, and its magnitude mod p bar minus q bar will be this minus 1 square plus this 3 square plus this 4 square, which will be 1 plus 9 plus 16 square root 26. Now magnitude of p bar is root 3, means length OP is root 3, and mod q bar is root 29, means length OQ is root 29. If point A is 5 minus 3 4, then vector OA bar will be 5 I cap minus 3 j cap plus 4 k cap, and unit vector in the direction of OA bar, say A cap equals A bar upon mod A bar. Now mod A bar will be square root of this 5 square plus this minus 3 square plus this 4 square, which will be 25 plus 9 plus 16, which will be root 50. So A cap will be 1 upon root 50 into OA bar, which is 5 I cap minus 3 j cap plus 4 k cap, which is this unit vector. Vectors A bar and B bar are non-collinear. We have to find x such that vector C bar, which is x minus 2 A bar plus B bar, and D bar equals 2x plus 1 A bar minus B bar. Since vector C bar and D bar are collinear vectors, we write D bar equals k C bar, where k is a non-zero constant. So it becomes 2x plus 1 A bar minus B bar equals k times x minus 2 A bar plus B bar, which will be 2x plus 1 minus k times x minus 2 A bar equals k plus 1 B bar. Now, as B bar and A bar are non-collinear, coefficient of A bar and coefficient of B bar will be 0. So we write 2x plus 1 minus kx plus 2k equals 0, and k plus 1 equals 0. That gives k equals minus 1. Substituting k equals minus 1 here, So this will be 2x plus 1 minus, putting the value of k, minus 1x plus 2 into minus 1 equals 0. This will be 2x plus x minus 1 equals 0. 3x equals 1. X equals 1 upon 3. So when x is 1 upon 3, vectors c bar and d bar will be collinear. A bar, B bar and C bar are three non-coplanar vectors. We have to show that for A bar minus 2B bar minus 2C bar minus 2A bar plus 4B bar minus 2C bar and minus 2A bar minus 2B bar plus 4C bar are coplanar. If these three vectors are coplanar, any one of them can be expressed as a linear combination of the other. So we write first vector for A bar minus 2B bar minus 2C bar equals x times minus 2A bar plus 4B bar minus 2C bar plus y times minus 2A bar minus 2B bar plus 4C bar. Here we have written the first vector, this, as a linear combination of the second, this, and the third, this, where this x and y are non-zero scalars that we will find. Now we write 4a bar minus 2b bar minus 2c bar equals minus 2x minus 2y a bar plus 4x minus 2y b bar plus minus 2x plus 4y into c bar. Now comparing the coefficients of a bar, b bar and c bar, we write this minus 2x minus 2y equals this 4, this 4x minus 2y equals this minus 2, and this minus 2x plus 4y equals minus 2. This equation becomes minus x minus y equals 2. This becomes 2x minus y equals minus 1, and this minus x plus 2y equals minus 1. We name them 1, 2 and 3. Now subtracting equation 1 from equation 3, we will change the signs. This will be plus, this will be plus and this minus. So x minus x will be 0 and 2y plus y will be 3y equals minus 1 minus 2 minus 3. That gives y equals minus 1. Now we substitute this y equals minus 1 in second equation. So that gives 2x minus of minus 1 equals minus 1. 2x will be minus 2, x will be minus 1. So we can write this equation with this x to be minus 1 and this y to be minus 1. Now since this first vector is a linear combination of the other two vectors, we can say that these three vectors are coplanar. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.